All right, here's a program. It's fairly simple, actually. It's not too bad, that will allow you to program your calculator so that you can create as many rectangles as you want to find rectangular area approximation for integrals. If you're doing this by hand, 4 or 5 rectangles is not too bad. 50 or 100 is way too many to do by hand. There's too much room for error. So using our TI-83s and 84s, I'm just going to walk us through a new way, a program actually, not a new way, but a program that we could use to create as many rectangles as we need to find area. So what we're going to do is we're going to name this program the RAM program for rectangular area approximation method. So this defaults automatically to the letters. It's got the alpha indicator up there. So we're going to look at RAM. And then it says to clear home. Well, a lot of the input that we need to use is under your program button. So we could go there for almost anything. And if we don't see it there, we'll explore some other places. We may get lost along the way, but hang in there, we'll get done. And right there, choice number 8, clear home, pick it, and hit enter. Then we're going to input, which is back under program, and we're going to IO, input, output. And then it says input, we're going to use quotation marks, so alpha plus, and then we're going to put number of intervals. If you hit the second alpha, it'll lock it so that you don't have to worry about anything, and then number of intervals. So now we're going to spell out that dude, and I hope I don't forget anything. And I'm squinting down here at my calculator, which is not as big as I would like it to be. And the space bar then is the 0. So you can get to the space bar by hitting 0. Number of intervals. All right, number of intervals. Here we go, right there. Okay, we're going to enter that. And then we're going to input. And we're going to put it in quote. Oh, I forgot to end quotes on this guy. So we'll just arrow key back up real quick and end quotes. We're going to input then, and we're going to put left endpoints, L. So again, we're going to add our quotes here. And if you hit second alpha, everything stays. So this would be left endpoint. And this is where we're going to start from. So when we actually have to do the problem, this will be the starter point, the left endpoint. And we'll finish that off with a quote. And then take off your alpha key now, because now we're going to put in a comma, and then we're going to go back to an L for this is what it'll tell you. Left endpoint, comma, L. All right, and then we're going to input the right endpoint R. So it's not alpha, it's program. Input, output. We're going to input, and then lock your alpha keys, put your quotes up. And this is going to be right endpoint. Whoa, what's going on here? Second lock. And then here we go. R. I. All right, right endpoint, and again, close with quotations. Turn off your alpha, hit a comma, and then we're going to put an R in there. So now it's going to. These are the two questions it's going to ask. It's going to ask for left endpoint, and then right endpoint, and then we're going to tell it the math that we want it to perform. So we're going to say what we're going to do is we're going to take that right hand number. So in parentheses, mathematically, right minus left, right minus left, close parentheses, and we're going to divide that by the number of rectangles we want, which is what we were asked. So divided by number of rectangles. And what this is going to do is we're going to tell this to store this as W. All right, we're going to tell it to store as W. So how do you do that? Hit the store button, and it creates a little arrow, and we're going to store this as W. And I'm picking W because it's in the directions that I'm using. Okay? No fancy reason why there. And then what we're going to do is we're going to sum up all those suckers. But not are we going to sum them all up. We're going to sum up a sequence of them. So what we're going to do is we're going to go to input output. And I think it's under input output. We want to sum. It might not be here. We may have to go on a small search. Okay, hold on one second. I found what we were looking for. So to find this sum item, it's going to be up here, choice 5, so you can follow the keystrokes. And we're going to sum up W, okay? We're going to take that W thing, which gives us our width, and we're going to multiply it with the whole sequence of rectangles. So again, back into that same spot. And I think there it is right there under ops. We're going to find the sequence. And then we're going to take, we got to tell the expression where we want to go. And so that's going to be the Y variable there. And this is going to be, not the Y variable, the Y function in Y1. We've got to give it a variable, which is going to be X. And we're going to start at the right endpoint. So we can, I believe we can go ahead and say our left endpoint here. We're going to stop at the right endpoint. And we're going to have a step of W. I believe this is going to be how it goes. We'll see when it looks in there. We may have to edit a little after we paste it. Let me look. Y1, X. We want L plus W right here. And then comma R. Comma W. And it would help if I locked my numbers. L plus W, comma R, comma W. And then we're going to close off all our parentheses here, which is, we've got 2 of them open. So we're going to close 2. And now I'm going to turn my letters off. Close both of those puppies. And we're going to store this as variable T. And we only need one store here, so take one of those guys off. All right. Then we're going to display. So we're back into the program menu. And we're going to disp, which is display, and then put your quotes back in, and we're getting ready to do some typing, so let's lock those guys for green. Display LRAM, which is going to be right here, LRAM. And what it equals. So we want to see that equal sign, and that is right here. And then close off your quotations. Followed by now, comma, and what we want to see. We want to see the T variable right here. That's your LRAM. All right. Then what we're going to do is we're going to do another sum. So we're going to do another sum. Whoop, wrong spot. And this time we're going to do W times. Uh-oh, I forgot to put a times in. With programming your calculator, you've got to make sure that you get everything just right. And if you don't, you'll have an error and it won't work right. So one thing that you can do is once you try and run your program, if you'll hit go to when it throws your error, choose go to, and it'll run through your program until it comes to the go to issue. Once it gets to that go to issue, you can change it, fix it. Maybe you can see where you have a mistake. But a lot of times there's some small little something in there that's not quite 100% right. And that's where we would go to make our change. So we want to do a sequence here. So let's see if we can find the sequence guy. Let's see. Where's that sequence at? I used him a minute ago. There he is. All right, now we had the wrong stuff in here a minute ago, so I'm going to go ahead and tell it to choose all of this and paste it in, and we'll just edit it. I'm sure there's a faster way, but this is at least the way that I know that I will get everything set up correctly. All right, so now we're going to go X and then L and then comma. Let's see. L, comma, R minus W, comma W. This is putting our variables in where they need to go. Close off those parentheses. Store that as T. And then we're going to choose display again, so that's program and input, display. And this time we're going to choose to display the RRAM. So this is right rectangular area approximation. And we're going to let it say equals so that we know what we're doing here. And then close your parentheses. And then put your comma in and tell it what we want to display. We want to display the T. And then this last one is the tricky one. This is the midpoint one. So it's going to look a little bit different. It's a little longer because now we've got to find the midpoint of the thing that we're looking for. So again, we're going to do a sum. So 5, we're going to sum up, and then W times, parentheses, another sequence of numbers. And again, I'm sure there's a faster way to fill it in correctly, but I'm going to go ahead and paste what I have here, and I'll just edit over it. So sequence, and again, we're going to have Y1, X, and L, but now we're going to have L plus, and then we're going to divide our width of our rectangle into 2. Okay, so L plus, not L comma, but L plus W divided by 2, close parentheses, then another comma, and then R minus W divided by 2, and put that in parentheses, and then close parentheses, and then a comma W. Close all your parentheses off, store that as T, and then our last little input here, we're going to display, and we're going to use our more typing, so go ahead and lock your alpha keys. We're going to display MRAM, and equal sign. Close your parentheses, put a comma in, and add T. And then we're going to tell our program to stop. And hopefully this will work out. We'll see. We've got one to try. So let's see here. Stop is F. All right, so there's our program. A little complicated, not horrible. So here's what we're going to do. We're going to stop that. We're going to go ahead and get out of our program. And let's go to y equals. And let's just try something complicated here. Let's go with x squared sine of x. Now, nasty little bugger. All right. And let's try running our program. So we're going to choose program. We're going to choose RAM. And once you have it chosen, hit enter. Oh, okay, here we go. We're going to go to go-to, and we're going to find where our error is. First error is quotations, number of intervals. All right, so I'm looking on here, input the number of intervals, comma, n, and we forgot to put the n, so I'm going to add that puppy real quick. All right, and let's try again. We'll see if we can't, number of intervals, that's what we want. So let's say something crazy like 10, okay? So then what we'll do is we'll just put a 10 in here. The left endpoint, so let's start at 0. The right endpoint, let's start at 3. And increments, let's go to, and we'll see where the next error is. So L plus W, comma R, comma W. So this should be a comma. All right, so here we go again. 10 intervals. Left endpoint 0, right endpoint 3. And there you go. There's your left and your right and your midpoint for this particular guy. And it tells you, it sums up all those things for you so that you know what's going on. So this is a really handy way to be able to do stuff. It's, you know, the more rectangles you put in, the more accurate you get, so that with 10 endpoints, notice I have some discrepancies here, large ones potentially. So if I run this program again, and let's put in like 1,000. Let's see if we can do it 1,000 So we're going to run it. We're going to put in 1,000 intervals. We're going to start at 0. We're going to stop at 3. So it's chugging. We've asked it to do a lot of math here. The little guy's spinning. So what's it going to pop out? And remember, on that first time through, we had a pretty significant discrepancy between 0.2 and 0.3. Now we got an invalid dimension, so maybe we had too many intervals in there. L plus W or WT. So let's see if I can do 500. So here we go, thinking again. There's your left, 0.35. Notice it's a little different now, a little more accurate. Here comes your right, 0.351. Notice these are closer numbers now than they were on the first time through. And lastly, 0.35. Notice these guys are grouped now a lot tighter together. And that's an indication that we have enough rectangles to get a good rectangular area approximation.